the command line version of SynchroSym. Now, maybe just before I start, we designed this exercise so that you didn't need any knowledge. We weren't assuming people knew R at all. If everybody in this course came in knowing R, then we would have done the exercise differently. I've set it up as a demonstration, but just a show of hands, who here has worked with R at all? So maybe 2/3. Yeah. Okay. So you got some idea. Okay. So I could have maybe done it differently, but anyway, this is what I've done. I've set it up as a demonstration. But the idea is you guys can take this R script away and run it on your own. That's the idea. We did the exercise last time. It was a kind of an after course exercise, but I think it's worth just talking it through so I can answer your questions about it. So to introduce it, I got a couple slides, and I am getting better at getting these slides up quickly. But not that much better. And we will just quickly go display, swap, and there we are. You can see my screen? Yep. Okay, so underneath SynchroSym is the user interface we've been dealing with is just a shell on top of the real SynchroSym, which is all driven from the command line. So all of the functionality, full functionality is available from the command line, so you can run this from Windows or Linux. Because it's all command line based, you can control it from any language. We have clients that run Python, prefer Python to R, and they've set up scripts very much like I'm going to do here, but obviously it's a little more cumbersome because they have to make calls to the command line from Python to do things. We and our clients, most of them work in R, and so we've had funding over the last 4 or 5 years to develop an R package, and we use it intensely ourselves. So there's more support if you're working in R than there is anything else, although we have on the books this year to develop a equivalent Python package. That's something that's been in demand and we will be doing shortly. But you get the same idea. So we're gonna look at how to interact with the command line today through R. But just to point out, there is a full command line available to work with in other ways. And so the intent of it is there is an R package. It's recently in the last 4 or 5 months made it up onto CRAN finally. So it's there, and we're planning to do more work on it in the next few weeks actually to get another version out. So what you can do then if you have this script, the command line version, is you can pre-process all your inputs. So instead of preparing them in Excel or hand typing them into the screens, you can prepare them all in scripts and suck them into SynchroSym and thus into STSym. You can create models rather than building them by pointing and clicking. You can run scenarios and you can post-process inputs. So if you add all this up, you can do end-to-end workflows. You can do everything from starting with your data down to your final report or manuscript figures, all done in scripting. And that's more or less the way we're headed with most of our work these days. But as you'll see, we still use the user interface in conjunction with R when we do it. So there's a couple of links here in your PowerPoint slides. One is to our documentation. Again, this is a subset of the documentation, but there is all the console commands are all described here. So it's well documented, fully documented, where you can have all the syntax, the command lines. So that's in really good shape, unlike some of the documentation for SynchroSym. And that's, for STSym, the SynchroSym documentation is in very good shape. And then as well, as I said, there's an R package. You can get it from CRAN, but there's a little bit of information here on how to, where to get it and the documentation associated with it. But because it's in CRAN, like all our packages, the documentation is all in line and kind of built into the package. I'm not going to look at the command line directly. I just wanted to point out that it's there. Oh, I shouldn't have left my PowerPoint just yet. I had another slide. Just a second. Now I'm getting really fast at this. So just a few concepts to give you an idea of how you would interact with SynchroSim from R. Here's the schematic that I showed you earlier with some of the nomenclature for SynchroSim. So in red are some of the functions in R that allow you to interact with these different elements in SynchroSim. And so again, this is a SynchroSim package. It works with any model that's in SynchroSim, of which STSim is one. And so there's a function to interact with the library. There's one, the names are fairly, I hope, make sense. You know, there's a function to interact with a project, interact with scenarios, to do runs. And then importantly, sort of the stuff that you work with mostly are the commands to move data sheets of data in and out of SynchroSim. And so you can bring data that's sitting in SynchroSim over into R using these data sheet functions, and they come over as you would expect as data frames. You can edit them over in R. You can edit them any way you like. You know, these days people use tidyr a lot more. You'll see I haven't put tidyr, if people are familiar with that, into this example today, but that's how we generally work. We manipulate our data frames using packages like that. And then there's a command when you're done editing to save the data frames back to SynchroSim. And so those are the essential functions that you kind of work with in this package. So now I'm just going to, any questions before I sort of flip into R and take you through a script just to give you a demonstration of it. Okay, so this script is, you have a copy of it in your course files. There's an exercise 7. There's an R script here. I'm going to run this from RStudio. Of course, it doesn't have to be RStudio that you run from, but that's what I'm going to do today. So this, I think, I point out in the exercise that you could also open this thing up in a text editor if you just wanted to look at it. But this is the package, and so, oh, this is the example in the package, I should say. Is that big enough, or do I need to make the font a little bigger? There's a command in here where I can go, and you remember you were pointing and adding packages to your base version of SynchroSim. That kind of functionality is available as well. I know that mine's already there. I think actually I didn't show it in here, but you can check what packages you have loaded. But let's just go down now, and I'm just going to do a couple things to set my working directory. So I've set the working folder in this example to exercise 7, my courses. I'm just looking at the files that are in there. And you can see that I've got here a library, a .sim file that I'm going to work with in this exercise. So far I've just set myself up the way I like to. I know there's lots of ways to do this, to be able to get at those files in that folder. So here's the first command that I'm going to use. I'm going to go and call this ssim library command and go grab a copy. It's actually making a reference to my library. So if I look at the contents of this object, I've gone and I've grabbed the library. Here's the library I've got. It's got some other information here, but it's really just a placeholder, a reference to the library that I can use to get other stuff out of. So the first thing I can do is go check and see if there are any projects yet in that library. And remember, we said before that we only had one project in here, and that's this one with the name definitions. That's what we've been working with, but it has a certain ID. So if I want to set some of the project level definitions, I need to know about that, right? So I can go and retrieve the project that's called definitions by using that project function. And now I've got hold of an object with the project in it, and here's this project that's got, it doesn't show its name here, but it's got the ID of 11. So these IDs become important in here, as you'll see. And now I can list all the data sheets that are available for an STSIM project. So this is going to be a fairly long list, but here are all the project and library scope data sheets. So, these are the different things that we call definitions, and here's the names. So let's just give you an example. The list of what do we just look at? Attributes. So the list of state attribute types that you entered, there's a table, called STSIM, state attribute type, that is available to me. So these are all the list of data sheets that are available that I can control and edit at the project level. So let's go retrieve one of them. I'm going to go get a data frame that lists all my state classes for my project level definitions. So I'll run the datasheet command to do that and then look at the results of that. So here it is. I've got a data frame here that lists my 3 state classes, what their label X and their label Y was, what their Raster ID was, their color code. So all the information that you saw earlier, if we go back over here, let's go look at them. Let's just close all of these. Let's follow along. File, let's open the exercise 7 library. This is what we're looking at. So I'm right now looking at all the project level definitions. So I have access to all this right now. I'm looking at this table here, right? This table here is appearing now over in R, right? As this, I put it into this object called my state classes. So that's the idea. You can get at all those definitions. Let's just look at running, going and getting a scenario now. So I can list all the scenarios that are available in my library. And in that library right now, it shows that I have one scenario with the name no harvest. I go over there again, and it's got an ID of 2. And if I was to go over here, that's showing me this scenario here with the ID of 2. Okay. Wonder if I can set these up side by side, or if that's going to be too constraining. I think I'll be okay. Except that that's going to disappear in a second. Okay, well, we'll continue on. That'll be easy enough. So now I've just run this line here. So now I can get hold of that scenario. I know there's one in there with the name of no harvest. So let me go and grab that scenario, that specific scenario, and I can look at it. And now I've got a handle on the scenario number 2. It tells me a little bit about it, but the important thing is that I can now go and run that scenario, and I can turn on the multiprocessing with 6 jobs. So I'm sorry, my RStudio is flashing a bit as I run this with the screen share on. So I'm now running that scenario from RSynchroSim. So I went and got to that library, I grabbed the scenario, and now I'm running it from R. Can't remember how long that one takes. And the next thing I want to do then is go and get some output after that run is done. Is it that long to run that thing? There you go, it's done. So it's run that scenario. And in fact, if we go over to R here, this is what we'll start doing, is running SynchroSim. I really should try and set this up to split screen here. Let's get rid of that. Let's just look at the side by side. Actually, I could probably just make SynchroSim smaller. Okay, so I'm running along. So I just ran this scenario. And if I go over here to SynchroSim, there's this button that refreshes the library. If I click on that, it updates the library. Now you see that in the UI, it's showing there's results now that weren't there. And if I click down here, the result of me running it from R is now available to me into the UI. So this is something we do a lot of. We run the two, usually on two different monitors side by side. And so I've just run that scenario. Let me just see if I can do something with it. Let's go, and this command here just gets me a list of all the data sheets that I could access for that scenario. And it's a long list, so I put it into a variable, and it's actually over here, this variable here. So here's a list in R of all the data sheets that are available to me in this particular library. So I can get at any input, and importantly, you'll start seeing there are a bunch of data sheets in here that have been hidden to me so far that have the output of a model run. And so they're listed down here. Actually, if I sort by output, I think they'll show up all together. So one of them, for example, that I'm about to look at is output. These are all the spatial. Where's the non-spatial? Where are they, Leonardo?
Sorry, I was in doing something else. What's the question?
Where can I find the output stratum state? Why is that not?
So I think it's output spatial.
Not spatial.
Oh,
Here it is. Output. Oh, it
yeah,
is.
output spatial stratum and output spatial state, right? Because there's a separate output for the strata and an output for the state classes.
All right, here it is. So this is an example. This is, I think, the one I'm going to look at. Output stratum state is a table that has my basic output by state. I think that's what we're going to look at next. And so, yeah, so I could go and grab one of those tables of data from my library by using the datasheet command and saying, okay, I want the data associated with this table here called output stratum state for the scenario that I generated by running my original scenario. So it's going to go, if I look at my results scenario, you're going to see it's got a scenario ID of 12. That's this scenario here of results. And I'm just going to go now and grab the raw output from the library. And so now what I've got is I've got a handle here once it's a big file. In fact, if you look here, output raw, it's got 200,000 records in it. So this is now a data frame of my raw output from that simulation. This is what the charting works on. So it has a record for, how much area was in on this iteration, this time step, and this state class at this age. This is how much area is there. So this is the very rawest output. And I can, I just looked at it, but we can look at that kind of output. This is the kind of thing you get. So now I have a handle here on my raw output. So this is an example, this first script, of what we would do. We might do a run, maybe in the user interface, and then we come in here and we just want to post-process it to do some charting or whatever, or some mapping. So this is an example here where I just have a command where I'm going to summarize that output. Again, if I was to do this today, I would probably use tidyverse to do this kind of thing, dplyr, if you know what that is. But I'm just going to run this command, and I've aggregated that output up now into a summary where I've summarized how much area there is for each time step and iteration by state class. And I can then average that over this is just got nothing to do with with our package. It's just some R commands to summarize stuff. And I can go grab just the conifer area and I can plot it. So here we go. We have a plot of the total conifer area over time. Not very pretty because I'm not using fancy R code. I'm not using ggplot, but you get the idea that I have a handle on my output and I can do stuff with it. And similarly, you can get out the spatial output. We can do a command which is called go get raster output. And I give it as arguments the result scenario I want and which form of raster output, again, is a data sheet. In this case, I'm just grabbing one raster for iteration 1 and time step 20, but I could get out all of them as a raster stack if you're familiar with the raster package. But this will just go grab a single one just for demonstration purposes. So I've grabbed a raster layer, which represents my the state of my landscape, the state class for iteration 1 and time step 20. And I could then, kind of like we did before, I have a handle on it. I can do whatever I want with it now in R. Here's that raster of the state class map, and I can do various things with it. So that's sort of examples of how to get hold of stuff and retrieve it, do runs, and post-process. This last task I'm just going to run through is just going to demonstrate how you can modify, actually the second last task, you can modify and then run a new scenario. So once again, I'm going to list the scenarios in my library. I now have 2 scenarios in there, if you recall. I've got the original one and the results scenario, but I'm going to go and grab the one called no harvest again, look at its name. It's the no harvest scenario. I grab that scenario. I'm going to make a copy of it. So you can in R make, with our package, you can make a copy of the scenario using the scenario function again. I'm going to give the new copy harvest 2,000 hectares a year. So I look at the new scenario. There's now, if I actually refresh this, I'll see that there's this new scenario been created. I haven't done anything to it, but it also appears here as ID 13 in my list of scenarios. I can edit the inputs of that now. I can go grab the transition targets. So if we look over here, we can look and see what the targets are. Their targets is just a single target with harvest of 0. You guys are familiar with that from the exercises you've done. So I can go grab that data sheet and just look at the structure of it. So it's a data frame with 2 columns, an ID and an amount. And the IDs are actually factors. So that's representing all the different transition types that you can have in there. And I can, again, using sort of stock R functions, add a row to it. So I've gone and I've added a row to that data sheet in R with a value of harvest type of 2000. And now I can use the save data sheet command to save that new data frame back to that scenario. And if I go over here now and refresh, and I look at this scenario that I've been working with, the 2,000 a year, look at its transition targets, lo and behold, there they are, they're 2,000 a year. So it's made the change for me in the library. And, again, we can come down here and run that scenario that we just created and look at the results in a second. It'll take a few seconds to run. And once again, when it's done, we can go over here and see that it's updated in the library. You're unmuted again, Stephen. No, not you. Somebody. And so, again, the run is done. We can look over here, we can refresh. So we've now got a results scenario in here that got generated by R. And we can, in fact, what we will do is we'll kind of run this and, I'll have a bigger screen. We'll have it on 2 monitors. But I can go now here and I can do stuff while I'm in R. I can, create charts, right? I can add these to my results and look at compare the transitions, do all the usual stuff we've done interactively while I'm working in R. So that's a really big feature, is the ability to go back and forth while you're working in R. And I'm not going to go through, you guys can try the last task on your own. I won't take you through it today, but this is a task where we're just example where we're creating a model from scratch. So you actually start with you create a brand new library from scratch, and then you build up all the data sheets so you can set all the project definitions, the terminology, the strata, the state classes, all that project stuff. You can create a scenario like we do here. We can set up the run control, the states that we want to include, all the probabilistic transitions, the initial conditions. They can be read in from rasters or not. I think these ones are not rasters, et cetera, et cetera. And so let me just, if I just run that whole thing, maybe I'll just run the whole thing at one foul swoop. Hopefully it'll all run. Actually, I gotta get the library from here. So let's go down and run all of this. So this is creating a brand new library. I'll go through a bunch of steps to do it. But if I look over in a minute, actually it's going to take a couple. Any questions while I'm waiting for it to run about running things from R? No, it all makes sense. Okay.
Colin, even I don't understand you're doing. I used to be a C programmer way back when, even a Fortran programmer actually. So it actually makes sense, but I just don't code in R. So, well, but I understand what's happening.
R is a bit of a mind bender to start. I always say that, when I went back to school and I've been coding like you, in all these languages and lots of experience, and I tried to learn R, and I felt like I was back in the 90s typing things in at a command line, and you type something in and it just says error, and the syntax of it's got to be one of the most difficult languages to learn, I think. And ironically, it's the first and maybe the only language most ecologists ever get exposed to. I always feel so sorry for these poor ecologists. I taught a course last semester, actually Tabitha was in it, and we start with, you're initiated into programming with R. It is a challenge. So Louis, it's not that easy to pick up. The syntax is different. Chris, did you have something you wanted to say?
Yeah, I was just curious to see, does the R package make direct calls to the code underneath the command line, or is it calling the command line?
It's just calling the command line.
Yeah. Okay. Yeah.
So the R Synchroson package is open source. It's on GitHub, and so you can see all.
Oh, yeah.
Actually, Chris, if you want to contribute to it one day, we're looking for people to contribute. Seriously, I mean, right now so far all the contributors have been pretty much in-house, but we're dying for people to come in but that's what it's doing. It's a wrapper on the command line. And the only exception to that, I think, Leonardo, is it's making some straight calls to go retrieve the output data. Remember I showed you that call where it got the raw output and it brought over 200,000 records? We found that it was doing that quite inefficiently through the command line, so we kind of do straight calls to the database now to pick that up. I think actually there may be an option to do it either way. Do you remember, Leonardo? Have we?
Yeah, so actually we're just fixing a bug in that this week. there's a couple of different approaches. So either calling the command line to just grab the raw outputs onto a CSV and go and grab them, and then go straight to the database using SQL. And then there's kind of this intermediate option where it, depending on the use case, this one's a bit faster sometimes. It sends a SQL statement to the command. The command line has an option to get a SQL statement to go and get the data.
So there's, but essentially, Chris, yeah, it's a wrapper on the command line, and that was kind of done purposely by design so that you know, we can the command line kind of is really stable, and that's an API that was kind of immutable, and so people can write against it and be pretty certain of it, including other people who want to develop packages. And, you know, it's convenient that we're the developers of the software and the R package, so we could do something more complicated, but it's a bit of a vulnerable way to do it that way. So that's why we do that. And most of the time, you're not concerned about, the only time we really care about performance in the interaction is when you're going and grabbing the output. I think that's the only time you really run into performance issues, yeah, that I've found.
Yeah, cool. All right, that makes good sense.
Anybody else? So,
yeah. Just a quick one. So when you were describing before, you could write your own code to do things at the end of each iteration, but it was a bit slow. Is that because it's reading and writing results to and from disk, or is there like some sort of direct way to do it all in memory?
The only way you can do it direct in memory is if you're willing to write your scripts in .NET. So our software is, you know, Synchrosim is written in Microsoft.NET. So if you're willing to, you know, we expose the methods there. So if you write a script in C#, you could compile it and do in memory, right? I don't know if anybody's, well, that's what we do with our STSIM is written in C#, and so it could take advantage of that kind of stuff. So that would be the one way you can pass in memory, but we haven't been able to, you know, that's I pushed for that, but right now it's transferring by file, yeah. So that's a performance bottleneck in connecting models for sure, a big one. It's something that we would love to work on. When I bring it up with our programmer or any programmers, they just tell me that, you know, doing in-memory transfers of data between different environments, like moving between R and .NET, is like next to impossible. I'd love to find people who've had experience with it to tell me otherwise, but that's why we've been limited to that so far. It's to be quite a monumental technical barrier to get over. Make sense? So yeah, this all ran. So if we look here, what I did is that, you know, that script created, just to show you, it created, where did it put it? Oh, there, new. It created this new library from scratch. So that's this exercise new, and so it basically built up everything you've been doing in this course, you know, all the definitions, all the scenario inputs, all the pathways, the probabilities, all of those just got created by that piece of our script. And that's actually the way we do most of our model development now. What I do find is the definitions, often we do by hand, like we do, you know, those project level definitions, because they're kind of one-off. We might do them in the interface, but as soon as it goes to creating the model, you know, some people, Louis, I don't know how your group works, but people decide at different points when they're going to start scripting versus do it by hand. But in our team, we tend to draw the line at the definitions and do most of the model development in code so that it's reproducible. Yeah.
They, in our case, they post a lot of the post processing and grabbing the stuff to do figures and all that's done in R by Kevin or Sarah. But when I build the models, I'm old school, and I work with the user interface and I build everything from scratch because while I'm building the models, I like to think about the ecology, and going fast is not always the best way of doing things. You have to think about this. So I approach it the old way. I need to noodle on these things so I can actually think about the ecology that's going into the model. That's why.
That's actually a really good point. So I should put that caveat on that I do the same. I usually prototype the model in the user interface, get it more or less working because it's quick and fast and interactive. And then once I've settled on a basic model, before I start creating a proliferation of scenarios, usually I'll hand it off to somebody else to reproduce what we've done in code, so we have it kind of solidified, and then we'll move on from there to do the analysis and all the scenarios. But there is still usually, I don't know, Leonardo, do you do the same? Do you start initially in the UI and get the initial model?
Yeah, it just comes a little more intuitively for me, and just getting something simple up and running fast is a little bit easier. But then for sure, for the full-on model and analysis in R. But often I go back and forth. Like I know some people that will, once they decide to start working in R, they'll only work in R. But I find sometimes it's easy to miss little things that you can see quite easily when you're just plotting your charts and stuff in the UI. So I find it valuable to use both.
Yeah, I very much do what I was just demonstrating here, which is have both windows open, even whenever I'm in R, to see what's going on.
And I discovered working with people who are, know R and can go back and forth, that when I asked them to build a model from scratch with the ecology, they're often incapable of doing it, or they have a very hard time. Where for me, it's just like immediate, it's easy, but then I can't do what they're doing. So it's when it comes to processing, doing these fancy figures in ggplot or other things like that, and grabbing the data. But when it comes to actually building the original model, the ecology, then it's my way or no way sometimes. So
yeah. So that's the end of that's all I wanted to show you on the R stuff, unless you have more questions. But you can try and run that script yourself. It should run for you. I hope so. It ran for me today, so it's a good sign.
Is this script, Colin, that you're using for the course, is it the same as the vignette for the R package, or is it slightly different?
Well, the vignette is an out-of-date version of this. Yeah. The vignette needs to be replaced in the next couple months because it's a vignette for ST. It's okay for this group because it happens to be a vignette that teaches you how to use STSim, but it's meant to be a vignette for SynchroSim in general. It's a bit too specific to STSim, so that's probably it's gonna change. We're gonna use a simpler example to demonstrate it without getting into all the STSim stuff. Or maybe we'll have two examples, I don't know. I haven't figured that out. But the documentation needs some upgrading for sure. I would go with this script because it's the latest thing that I've done. So it's the most up to date and it matches your course. Okay. Any other questions? No? Yep. Okay, next on the agenda, I have, Jesus, I'm keeping right to schedule. We're going to look at some advanced features for a bit. So we got 45 minutes left.